Hi guys, welcome back to a new IMONST video. So in this video, we'll be finishing last year's IMONST questions with problems 18, 19, and 20 from the senior section. And I'll just give a brief solution for all of these, and then yeah, that's basically it. Now, let's look at problem 18. So we have a triangle with the ratio of interior angles being 1 to 5 to 6, and the longest side has a length 12. One is the length of the altitude, height of the triangle that is perpendicular to the longest side. Okay, so we know that we have 1 and 5 and 6 over here, right? So the sum of interior angles of a triangle is 180 degrees. So the one in here will represent times 180 degrees will represent 15 degrees, and then the 5 here will be representing how many? This will represent 75 degrees, and then the 6 here will be representing 90 degrees. So as you can see here, we can kind of construct a triangle of this kind of magnitude. Okay, then the longest side, being the hypotenuse, has length 12, and then what it wants is the length of the altitude perpendicular to the longest side, which is this one. So how long is this? Okay, now initially we'll be taking this, so we will have 12 sine 15 over here, and then we will have 12 sine 75, or you could say 12 cos 15 over here. Okay, now we have two solutions stemming from here. The first solution is to use the double angle. So double angle basically means sine 2a. Okay, you know what sine a is, but sine 2a also can be expressed in terms of sine 2a, which is over here 2 sine a cos a. So we need to use this wisely. So what we can do here is we use the 12 sine 15 and 12 cos 15. So we know that the area is in fact 12 sine 15 times 12 cos 15, okay, and then times a half, because this is a triangle, base times height divided by 2. We will have 12 times half would be 72, and then times sine 15 cos 15. Right, now we need to take out a 2 from here, so we will get here 36 times 2 sine 15 cos 15, which we can see here is 36 times sine 30, because the angle's value is doubled. Now, since we have 36 times sine 30, and then sine 30 is a special angle, we know its value is a half, so we know that this triangle's area is in fact 18. So now, letting this height that we want to find be h, so we know that 18 equals to 12 times h divided by 2, which is equals to 6 times h, right? So we just move 6 to the left side, meaning divide both sides by 6. Now we will get h equals to 3. So this is one of the solutions. Now the other solution is a bit more complex, but basically it involves addition of angles. So what we want to use here is 12 sine 15 and 12 sine 75. So what we see here, we know that sine 15 equals to sine 45 minus 30 degrees, right? And for this one, now let's move down a bit. So sine 15 equals to sine 45 minus 30, which is, it's a formula. You guys can learn it from somewhere else, okay? Sine 45 degrees times cos 30 degrees minus cos 45 degrees, and then times sine 30 degrees, and then these are all special values, so we just list them out. Root 2 over 2, then this is root 3 over 2, minus this is root 2 over 2, and then this is a half. So we would have root 6 minus root 2 over 4. Okay, so this is the value of sine 15. Now, for sine 75, we would have sine 45 plus 30, which are again both are special angles. So we have sine 45 cos 30 plus cos 45 sine 30, which gives us root 2 over 2 times root 3 over 2 plus root 2 over 2 times a half. We will have root 6 plus root 2 over 4, okay? So now we know these already, right? And then what we want is the area again, so it will be 12 times sine 15, which we have this one here. And then times 12 times 12 times sine 75, which is this one here, and then times a half. So basically what we have here is 3, and then this is 3. So we have 3 squared, which is 9 times this one is a plus b, a minus b, so we can basically make it into something like a squared minus b squared. So 9 times 6 minus 2 times a half will also get us 18, and then for 18 you just do the same thing over here. And basically this will be how we solve problem 18. Of course there are also other solutions, and then if you do have them, do write it down in the comments below. Maybe I can review them, I'm not sure. Okay, now for problem 19, this solution is actually suggested by a friend of mine named Ivan, and then I thank him for his suggestion over here because it was an eye-opener. Because me personally, I solved the question, but I didn't know why it was so, and then he kind of just dug deeper and then gave me the whole gist. Okay, now a set S has 7 elements, so let's list out 7 elements. Let's list out numbers. Okay, so 1, 2, 3, 4, 5, 6, 7, right? So several 3-element subsets of S are listed such that any 2 listed subsets has exactly 1 common element. Okay, so let's say one of these subsets of S, let's say it's 1, 2, 3. So our next few subsets can have 1, can have 2, can have 3, but cannot have like 1, 2. Oh, this is not permitted. Or it cannot have 2, 3. Oh, this is also not permitted. And then 3, 1 also not permitted, right? So we can only have 1, 2, 3, and then the rest should be with other elements, right? So what is the maximum number of subsets that can be listed, right? So if we want exactly 1 common element, we don't want 2 common elements. Okay, now let's kind of dissect this subset. We can dissect this into, again, 3 subsets, 3 pairs, namely 1, 2, 1, 3, and 2, 3. So these are the 3 pairs hidden in this 3-element subset of S. Now what we want is for all of the other 3-element subsets, we don't want any of these to appear, right? So let's kind of list out how many pairs are there in this whole 7 elements set. Okay, so for a 7-element set, the number of pairs that you can find is basically 7C2. If you know with the combinatorics, it's just choose 7, then choose 6, and then divide by 2 is 21. So we have 21 pairs over here. So it's not just these, we also have 1, 4, 1, 5, 1, 6, 1, 7, 2, 4, 2, 5, 2, 6, 2, 7, 3, 4, 3, 5, 3, 6, 3, 7, 4, 5, 4, 6, 4, 7, 5, 6, 5, 7, and lastly we have 6, 7. Okay, so these are the basically the all the 21 pairs that you can find in this set S. And then what you want is you want all of these to appear exactly once. Okay, so appear exactly once. Now to let it appear exactly once, such as this thing here, what we want to do is we want to divide all of these 21s. We want to divide all of these 21 pairs into groups of 3, right? Because 3 of them will make one 3-element subset. So what we would just do over here is just basically 21 divided by 3, and we can get a 7 3-element subsets. Okay, sorry for my anxiety. Okay, so basically this is it. And if you want me to list out an example, give me some time. Let me think of one example. Okay, so we have 1, 2, 3, 1, 4, 5, 1, 6, 7, 2. Then okay, so for 2 it'll be 2, 4. What? It'll be 2, 4, 6, and then we have 2, 5, 7. Then we have 3, 3, 4, 7, and 3, 5, 6. Yeah, basically this is one example. And then you couldn't go way further than that because all 21 pairs are hidden inside here. Okay? So this is the solution to problem 19. Now, let's move on to the last question of this whole paper, and then we can basically call it a day. Now, Geeta wants to cut a cube of size 4 times 4 times 4 into 64 unique cubes of size 1 times 1 times 1. Every cut must be straight and parallel to the face of a big cube. What is the minimum number of cuts that Geeta needs? Now, note, we need to emphasize this part because this girl Geeta, she can rearrange the pieces before cutting again, right? So she can cut more than one pieces again. So these two are important conditions. So let's draw a 4 times 4 times 4 cube. Okay, it will look something like this. No, it's a bit ugly, but please do not mind. Okay, so something like this, and then these are the lines to be cut. So move down. Then we have this. Okay, so this is one side. Then finally we have the last side, which is this one. Okay, so if you do not move this whole cube, you just let it cut as it goes. As you can see here, we will need 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would need 9 cuts. But of course, obviously, this is not the minimum because as the question has specified, she can rearrange the pieces before cutting again. So, what Geeta will want to do is, for the first cut, she'll want to cut the blocks in half, right? So, cut in half. So, after that, what she will have to do is, so for these blocks of half, right, you can arrange them as such that it becomes a bit of something like this, right? So now we have 4 times 4 times 1 blocks, and then what we'll have now so this one will give us 2 pieces, and then this one will give us 4 pieces. Now what we will have right now, if we rearrange this back into a cube, we will have something like this, right? So what we want now is to cut over here. Then we will have 8 pieces. So you see, it just doubles every time, right? So now we arrange. So what we do is we bring this part over here. So we'll have something like an 8. Okay, 8 of these. Something like this. And then lastly, yeah. Then for this one, just cut over here. And this will give us 16 pieces. Now, 16 pieces, then we move down a bit. So basically what we have now is just if we rearrange this back into a cube. Okay. Now what we have are these. Okay, now we have 16 1 times 1 times 4 blocks, right? Now for this one, basically do the same thing again. Now cut through the middle. And then our girl Geeta will have something like a 32 blocks here. Okay, something like this. And then, okay, it's not the prettiest, but anyway. So we have, okay, no, sorry. This one I need to erase a bit. So this one, we will cut and then we will have 32 blocks. So something like this. 1, 2, 3, 1, 2, 3. Okay. And for this one, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then you cut this 8 through the middle again. Then this one will have 32. Then finally, this one will produce 64 blocks as we have wanted. Right. Yeah, so this is the best way to cut it into 64 pieces because every time you cut the amount of the cubes, the amount of blocks just double. So 2 to the power of 6 is 64, as you can see here. So the answer to question 20 is 6. Now, so basically this is the solution. And why is this so? Maybe you guys can ponder a while, and then maybe if you guys have any ideas why this is so, you guys can write it down in the comments. Okay. So basically, we have finished the entirety of IMONST 1 2020. And yeah, hope you guys went through this journey smoothly. I don't know, I can only provide this much. So if you guys are taking IMONST this year, I wish you the best of luck. Okay, ciao ciao.